Hello everyone and welcome back to Tall, also known as Teach as We Learn. Today we're going to be learning about quadratic transformations. So let's begin. So in the last couple of videos, we learned that a quadratic function is basically a U-shaped graph, or what we call a parabola. And then we learned about vertex and yada yada. However, there are many different types of parabolas and those U-shaped graphs. But however, this right here, remember that fx can also be, is just another name for y. So y equals x to the power of 2 is our parent function. Meaning that yes, the graphs will change over time, and stuff like that, but this is the template, or this is like the original, which it sticks to, and whatever is changed will be changed after this. So this is like sort of like the first, but what we call an algebra is the parent function. So when we had this parent function, or like our original parabola, or original quadratic function, then the ones that keep on changing will be based on the parent function. And what I mean by this is we have y equals x to the power 2 plus 1. And we can see that basically whenever it is something is being added to the x to the power of 2 or subtracted, then we can tell that it's vertical, meaning that it will either go up or down. In this case, it's plus 1. So instead of starting at the origin, it started at 1 and basically just went 1 unit up. Each coordinate went 1 unit up. So for this, we would say that the graph moved 1 unit up. And that's pretty much it. So whenever we get this, y equals x to the power of 2 minus 2, then we sort of say it's the same thing. That since it's minus 2, instead of going up, it's going down 2 units down, right? Because instead of starting at the origin, it starts at minus 2. So the graph moves 2 units down. So this is basically vertical, basically just moving a unit up or a unit down, moving up and down basically. And these are typically the most easiest to identify, because if it's after the x to the power of 2, whatever is added or subtracted, that will just depend if it's moving up or down. But then we have this, y or fx equals x minus 2 to the power of 2. And a rule to keep in mind is whatever is changed in whatever is different and it's in parentheses, that means it's going to move right or left, meaning horizontal. It's going to move horizontally, so it will either move right or left. And another rule is, which tricks up many people, is that since it's minus 2, you would expect that it would start at the left, right? And minus 2 here. However, whatever is in the parentheses, like minus 2, we do the opposite of it. So technically, the parentheses is telling us to go to 2 units left, but instead of zooming it to minus 2, we're like, oh no, that's plus 2. And that's the reason why in this graph particularly, it is going plus 2. Because we did the opposite of what the graph told us. So if it's in parentheses, we know that we're going either left or right, and then you just do the opposite of it. So in this case, it's in the parentheses, so we know we have to go left/right. But since it's plus 2, we do the opposite to minus 2, and that would mean that the graph would start 2 units to the left. And then we see right, left, up, or down. However, that's not quadratic transformations is not only just that of just moving 2 units right or 1 unit down. It's more than that. And when I mean more than that, these quadratic functions can either become larger or smaller. And in algebra, we also have 2 key terms of what we call. One is vertical stretch, and the other is vertical compression. Sorry if I said that or spelled that wrong. But we have vertical stretch and vertical compression. So let's take an example of this graph. We can see that there are no parentheses, sort of indicating that there's no horizontal change, and there's not anything written on the side, which tells us that it's moving up or down. Instead of being x to the power of 2, like our normal or our parent function, it is 2x to the power of 2. And this, we can tell, is a vertical stretch. And the reason that it's a vertical stretch is that any graph which is greater than x to the power of 2 is a vertical stretch. And we can also determine vertical stretches by how they become less wider, they become more narrow in size, but they go taller and taller in height. I know you can't really tell with this graph, but maybe if you go to Desmos yourself and check it out on the graphing calculator, you'll see that vertical stretches have 2 things. That they become more narrow, but they stretch or become longer. If you do not want to do that, then just remember, since it's 2x to the power of 2, it's greater than x to the power of 2 or 1x, which made it a vertical stretch. So when we have a compression, then it's the opposite, right? So compression is basically when x is less than 1/2. And the thing is, we can see how it became wider. So that's the main takeaway of a stretch, of a compression, is that it becomes wider and less narrow. So, right, shrinks, but it becomes really, really wide. And since this is less than 1x and has become 1/2x, we can see it's smaller and making it a compression. So this is it for today's video. I hope y'all enjoyed and understood it. The next topic which we'll be learning is factoring, which is quite easy but has a lot of methods. But anyway, see y'all next time, and I hope you enjoy.